Hi, welcome to lesson 1. In this lesson, we are introducing the concept of limits and continuity. So in this course, Elementary Calculus, we'll be trying to discuss problems that deal with issues of studying change of different functions. So in this course, we have 3 units. The first unit is limits and continuity, and then we have differentiation, and finally integration. So in calculus, it actually stems from the problems that you were looking earlier on before coming to this course on geometry. So in geometry, remember we're looking at finding the tangent of the line, determining areas of different planes and regions. So as we build up on the study of changes, it actually gets quite interesting now by looking at problems that we're going to try to look at different functions and try to find the change now in a totally different approach. So this is really fundamental for someone who is looking at statistics, because later on in statistics, as you study statistical testing and other topics in statistical inferences, you would observe that you need an understanding of calculus to be able to deal with some problems. And you will later on see how this is applied when we get to your second year. So in this part, I will start off with discussing the definition of a limit of a function, and then look at one side the limits, and finally the existence of limits. So limits are actually just focused on variation of a function. Remember when we were plotting functions earlier on, we tried to come up with a table of values to say, okay, that when the value of x is, let's say, 2, 3, 4, and so forth, what is the value of y going to be based on the function that have been given? And in that case, we are sort of looking at the variations of y dependent on the values of x. So let us also be able to appreciate what is happening. So for instance, consider this function f of x, which is equal to 2 of x. What does the value of f of x approach as x approaches 2? So remember that we can directly just punch in to say, okay, what is the value of f of x when x is 2? In this case, it's actually 4. But now what we want to know is, okay, if we are approaching x from maybe, let's say, the right side or the left side, what are these values of f of x, or which is our y in this case, going to be approaching? So which is now looking at the variations. Okay, are we approaching x from this side from 0 towards 2? Or maybe are we approaching for maybe a value 4 or 5 towards 2? What are the values of y going to be approaching? So it's time to study that variation in this case. So we can actually come up with a table of values. And in this table of values, for instance, we start from the left. You look at, okay, let's say we start from 1.5, 1.9, and then we move 1.9999. We're not getting exactly to the value of 2, but then, okay, as we are approaching 2, what are these values of f of x approaching towards? And you can observe we're moving from 3 and heading towards 4. Similarly, when you're looking from the right side, as we are approaching x on the right, where it's taking values that are greater than 2, but actually approaching closer and closer to 2, you can observe that the value of f of x is moving from 5 and then heading towards 4. So as we're approaching from the left and from the right, we can see that the values of f of x are approaching 4. So this is now what is going to be looked at as the limit of this function. So which is more or less like a bound. So, okay, whenever we're approaching from these directions, this is what we're going to be heading towards. So you can note that this function f of x equal to 2 actually is defined when x is equal to 2. You can punch in, you can see that the value is 4. So meaning that whatever the limit was approaching towards is actually what the function is at that value, which later on when we're looking at the concept of continuity, you would appreciate more as to saying, okay, the limit and the equality to the function itself, what is it all about? Okay, so let's now look at a definition of a limit. So a limit can be defined as, suppose f of x is defined when x is close to a, then the limit of f of x is L as x approaches a. So we write it as this. So this is no notation for a limit. So this is only possible provided that we make the functions f of x as close to L as we want for all x sufficiently close to x. So that is from the both sides of it, from the right and from the left. If we're approaching that value, then actually this is what our limit is. Okay, so the next, we can also denote it in this form, where you say f of x approaches L as x approaches A. Okay, so remember when we're looking at the problem earlier on of f of x being equal to 2 and trying to approach from the different values from the right and from the left side, you can observe that we're looking at an approach from the left and approach from the right, which is actually what is now heading us towards the concept of one-sided limits. So the one-sided limits is now where we're trying to find the limit of a function as maybe as the value x is approaching maybe a certain value a from the right side, meaning that it's approaching from the values that are greater than the value a itself. And also we can also look at, okay, what is the limit as x approaches a from the left side. So which is now what we have, the right hand limit and the left hand limit. So the right hand limit is actually denoted as limit as x approaches a, where you have a plus sign here, f of x is equal to L. So that is the right hand limit. So provided that we make f of x as close to L as we want for all x sufficiently close to a and x greater than a, without letting x be a. And the left-hand limit is where you're saying limit as f of x approaches a. So you can see the left-hand limit here, there's a superscript of negative f of x equal to L. So this is a case provided we make f of x as close to L as we want for x sufficiently close to a, where x is less than a. So you can note that this limit as a plus, it actually means that we are approaching from the right. And then this with a negative, it means that we're approaching from the left. So that is what we're talking about here. So we're approaching from the right. You can see here we're moving from values that are greater than a towards a. Here we're moving from values that are less than a towards up towards a. So these are the left-hand limit and the right-hand limit. Okay, so this concept, actually, in this case, we can be able to also look back at the example we had earlier on to say that in this case, as x is approaching from the left, which is now the left-hand limit, we can see that the values of f of x is approaching 4. So meaning that our limit is actually 4. And also from this part, you can see from the right, as we're approaching from values that are greater than 2, you can observe that the value of f of x is approaching 4, then our limit in this case is 4. So which now here brings us to the concept of existence of a limit. So when do we say that actually a function has a limit or not? So we say if a function has no limit, then we say the limit does not exist. This condition, the condition that guarantees the existence of the limit is if the right-hand limit is equal to the left-hand limit. So remember earlier on we looked at the computation of how do we find the right-hand limit and then how do we find the left-hand limit. So when these two values that we find are equal, then in that case we're now going to say that, okay, this is what our limit is. So in this case, if the limit as x approaches a, f of x is equal to the limit as x approaches a from the left-hand side is equal to L. If these values are the same, then the limit exists. That means we say that, okay, the limit as x approaches a, f of x is just equal to L. Okay, so similarly, if you know that this limit is existing, then there's an implication underlying to say that actually the left-hand limit and the right-hand limit are existing and they're equal. But if these two values are not the same, the left-hand limit and the right-hand limit, they are different values, then in that case, the limit does not exist. Okay, so that's how we look at the existence and non-existence of a limit. So what is one of the ways that we can find out about the concept of limits? So one of the approaches is now what we looked at earlier on, the table of values. So we can come up with a table of values and then see what are the values approaching towards, and then we say, okay, this is the left-hand limit or this is the right-hand limit. But the other approach is now by observation. So you observe from a graph to say, given a graph of that function, you observe that, okay, what are the values of the function trying to approach when we have this value? So for instance, in this example 1.1, we're going to look at a graph of this function f of x. So we've been given this function and we want to try to find out at different points, let's say 3 or maybe -3 and 1, what are the values of the function heading towards. So let's start off with this part. The limit as x approaches -3. So the limit as x approaches -3, we need to look at, okay, what is happening when x is approaching -3 from the left-hand side or from the right-hand side. So you can observe in this case that, okay, as we are approaching from this side, going up, the values here, this way, the function is going up and up and up, heading towards 3. Similarly, when we are approaching from the left, from the right-hand side, which is the values that are greater, you can observe that it's going up, 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 up towards 3. So in this case, actually, the limit of this function is 3. So the limit as x approaches -3 of the function f of x given by this graph is actually +3. Okay, so let's now observe what is happening when x is -1. So if we're looking at when x is -1, when we're approaching from the right-hand side, from 0 towards -1, you can observe the function is going down towards 2. So actually, we can say the right-hand limit is 2. But now, when you're approaching from the left, you can observe a different trend altogether. The function has actually flattened up to the case where it's getting towards 1. So meaning that from the left side, we are approaching 1, and from the right-hand side, we're approaching 2. So we can see that the right-hand limit and the left-hand limit are not the same. So actually, it means the case that the limit as x approaches -1 does not exist. So because these two limits are not equal that you're finding here. So this is actually just been summarized here. You can also read through this and be able to appreciate actually what is happening. Okay, so we can go a step further to look at some interesting examples where you can try to think through from this other book that I have here. So we've been given different graphs here, and we want to find the limit at indicated points. So for instance, in this case, they're looking for the left-hand limit as x approaches 3. So we say, okay, what is x approaching 3? 3 is from here. So since it's the left hand, you're looking from this direction. We're moving and we can observe that the function is actually heading towards 1. So our limit is 1. Whilst in this other problem, they're asking us for the limit as x approaches 3, -3. So we need to find the left-hand limit and the right-hand limit. So you can see that when you're approaching from the left, you can see that the values are actually heading towards 2 in this function. And when you're looking at from the right side, you can observe that the values are heading towards 2 as well. So that means our limit is actually 2. Okay, so that's how we can be able to find limits of functions. All right, thank you. So this is the end of our first lesson. Then we can now look at our second lesson.